Hi, everybody. This is the Unit 2 pre-assessment or your study guide for the Unit 2 post-assessment, which is mainly adding and subtracting with fractions and some mixed numbers. So here we go. Number 1 is add or subtract. We're looking for a common denominator, step number 1. Kids could look at this and hopefully could just list off all the common denominators for 6. It might be 6, 12, 18, 24, 30, and so on. And the denominators for fourths might be 4, 8, 12, 16, 20, and so on. And we're looking for which number they have in common, so we could see a 12 and a 12. So our common denominator is twelfths. Get rid of this out of the way. So we have something over 12 plus 2 and something over 12. And then we ask our kids, how did the bottom change? It's 6 times 2. So 1 times 2 is 2. So 1/6 is equal to 2/12. And then how did the 4 change to 12? It's times 3. 1 times 3 is 3. And then we could just simply add the numerators. 2 plus 3 is 5. The bottom stays the same, 12ths, and nothing plus 2. Our first answer is 2 and 5/12. And B, just a little bit quicker. Common denominator here could be possibly 18 if the students multiply them together. That would work. Or you might pick 12. Or we're asking our kids really to see if they can find the best common denominator, which would be 6 this time. So we have 5/6 plus something over 6. 1/3 would be how many sixths? That's times 2. So 1 times 2 is also 2, which gives us 7/6. That is an acceptable answer. We'll take that correct on the test. Or we can pull out 6/6, which is 1 whole, and we'd have 1/6 left over, which is the best answer. But I would take either or. So on the answer line, we'll just put the best answer, which is 1 and 1/6. Letter C switches over to subtraction. Same thing. If you look at this, it's the exact same problem. 5/6, 5/6, 1/3 and 1/3. So we can use the exact same thing here. 6 as our denominator. And that's a 5. 3 times 2. 1 times 2 is 2. But this is subtraction this time. So 5/6 minus 2/6 would equal 3/6 or 1/2. Both answers would be accepted as correct. We'll put in here 1/2. Let's clean this up a little bit. And then our last one is 1 1/5 minus 3/10. Probably the hardest problem up on this top. So first of all, we always need to start with a common denominator, which in this problem, hopefully students can see we can use 10. And this fraction did not change at all on this side. So that's 3/10. How did 1/5? What would that look like as a tenth? It's times 2 times 2. And now this is the hard part, is what's 1 and 2/10 take away 3/10. I could see students maybe possibly trying to do 3 minus 2 and put a 1 up here. The best way probably to think about this is how many tenths am I away from 1 whole? That would be 7/10. So I get to the 1 whole, and then it's 2/10 higher than that. So we need to get to the answer of that's 7/10 plus another 2/10. We need to get to 9/10 somehow. Students possibly could change this 1 whole to 10/10. Scribble that out. And then you'd have 10/10 plus 2/10. You're really subtracting now 12/10 minus 3/10, and that's where we get that same answer. So a couple different ways to think of that one. So 9/10 is our final answer for that one. Scooch down a little bit. Same thing here in number 2, except this time they're asking us to find the common denominator here with rewriting the fractions out. Same thing we did on the top, but this time our students will get a point for this answer blank, and this. So A is going to be worth 3 points. Common denominator here would be 6 and something over 6. 1/2 times 3 and times 3. So we know that 3 out of 6 is the same as a half. And then how did the 3 become a 6? Times 2. 1 times 2 is a 2. Add it up, and we get 5/6. So same kind of thing here. Common denominator here for 15 and 3. I would pick 15. So it's 3 and 4/15 did not change. This would be 2 and something over 15. We don't know. So we have to ask ourselves, how did the 3 turn into 15? It was times 5. So 1 times 5 would be 5. And now we could add up the numerator. 4 plus 5 is 9. The bottom stays the same. And the big number is 3 plus 2 is 5. We could simplify that one if we wanted to, or you might just leave that answer just like that. If we divide by 3 here, divide by 3, we end up getting 5 and 3/5 is our final answer. But both of those would be correct. Letter C, we do not have common denominators. We need to find that. I would pick 10. Students might pick 20, 50, 100. Any of those would work. I'm going to pick 10. 10. So this second fraction did not change. That goes on this line, the second fraction. The first fraction goes on this first line, so that's times 2. 3 times 2 is 6. 6 tenths minus 4 tenths is 2 tenths or 1/5. Both of those answers would be marked correct. Letter D, common denominator, 8 and 16. Hopefully our students can pick 16 and 16. First fraction did not change. This fraction would be times 2 on the bottom. Whatever we do to the bottom, you must do to the top. 5 times 2 is 10. So it's 10 sixteenths minus 10 sixteenths, which would be 0. Okay. Moving on to number 3, get a little bit away from that adding, subtracting. And now this time it's asking us what is 1/3 of 27. There's a whole bunch of different ways to think of this. You might just draw like a little number line. And if the whole number line is 27, we're splitting it into 3 equal parts. So 27 divided into 3 equal parts. 27 divided by 3 is 9. So 1/3 would be worth 9. And there's our answer. If we continued, we can find out what 2/3 would be. 9 plus 9 is 18. And then 3/3. Oh, that makes sense. 9 for 1/3, 18 for 2/3, 3/3 would be 27. Our answer, all we need to write down, is 1/3 is worth the number 9. 1/12 of 60. So we can clean this up. We can do the same way. Number line here. We have, this time it's worth 60. And we're dividing it into 12 equal parts. So it's going to be really hard to figure out how to divide this into 12 equal parts. So we can have half, fourths, eighths. But if we keep doing that, we're not going to get right to twelfths, which is going to be kind of difficult. So all we really need to think of is pretend we have 12 equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Let's double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal parts. And we have 60, so we're doing 60 divided by 12. 60 divided by 12 equals 5. Sorry about that, 5. So this would be worth 5 right here. 1/12 equals 5. Our students have been practicing these a lot. They just kind of know, like, hey, if I need 1/3, I can just divide that number by 3. If I need 1/12, I can just divide that number by 12. But this is kind of showing why it works. Come down here, it's kind of the same kind of problem, but they're going to use like a story real life problem. Mark drove 3/4 of a 36-kilometer trip before he stopped to get gas for his car. How many kilometers had Mark driven at that point? Show your work using words, numbers, or labeled sketches. This is a perfect sketch right here. We can say he drove a total of 36 kilometers, and we need to find out what 3/4 is. So 3/4 is much easier to cut compared to twelfths. We have half. Oh, I know what that is, 18. And then half of a half is 1/4, which half of 18 would be 9. So we're going up by 9s, plus 9, plus another 9 here. 18 plus 9 would be 27, plus another 9. That makes sense. 4/4. This is halfway. So this would be 3/4, and that's what the question was asking us. Let's double check our question. How many kilometers had Mark driven at that point? He had driven 27 kilometers. And we are going to pause this video right here. Possibly.